Good morning. Good morning, Sarah.
Hello. Can you hear me okay?
Yes, I can hear you.
All right.
Okay, we will give it a couple of minutes for people to join. I see there are more than 20 registrations, so I hope people will be joining.
Okay.
I hope we didn't have any issues finding the link and joining.
No, I found like a page to register, so.
Okay. We'll wait until 10, like 10:05, and then we'll
Okay.
start.
Sounds good. I'm just gonna mute myself and turn my video off and get my slides pulled up. But I'll be here.
Sounds good. Sounds good. Welcome, everyone. We are waiting for a few more minutes for people to join, and then we will start.
Can you guys just confirm that you're seeing my slides?
Yes, Sarah, yes, we are
Okay.
seeing your slides. I think
Just making sure you can see the slides and not my slide notes.
we can. And it is 10:05, so we can
Yeah.
get started. I know some people will keep joining as we go. We have more registrations here, but we will start and then people will join as we go. So good morning, everyone. I would like to introduce you, Sarah. Sarah is the Chief Marketing Manager for NIRF portfolio, and she has more than 15 years of experience in test and measurement on wireless communication and RF technologies. And of course, Sarah has spent most of her career with SDRs. I just learned you spent 4 years at Keysight, and you were also leading the 6G marketing strategy at Keysight. So that's great. And Sarah has been active also in the community with industry groups like NextG Alliance and participated with advocating for improving sustainability and making wireless technology green. So Sarah, welcome. And today Sarah will be talking to us about 3G GPP update, the latest news regarding the 6G cellular standards and how all of these things relate to test beds and RF and advanced wireless. Welcome, Sarah.
Yeah, thanks for the introduction. So, um, I know that the 3GPP can oftentimes be difficult to follow. There's a lot of meetings, a lot of documents, and so I wanted to just go ahead and share updates about um, things that are going on. And I'll also say I have slides. I can talk to the slides the whole time, but I'm open to questions. The way my screen setup is, I cannot see the chat at the same time. So if you have a question, just come off of mute. Feel free to interrupt me, and let's make this as interactive as you guys like. So to start off with, I'm just going to give a quick overview of what the 3GPP is and how it functions, because there's a lot that goes on into it. Talk a little bit about the timeline and then get into more of the technology updates. So what is the 3GPP? I know we no, maybe this is familiar to some people, but I know when I started doing more work on the standards, it wasn't initially obvious to me, how everything functioned in the entire community. And so the 3GPP is an industry consortium, and they actively take in requirements and generate technical specifications. So there's another organization, the ITU, International Telecommunications Union, and they're the one that actually develop the recommendations for what should go into the next generation of standards. So they take inputs from other working groups like IEEE, they look at Wi-Fi Alliance, and they generate these requirements. From there, the 3GPP has their meetings. It's very consensus driven where there's different organizations that go and contribute. And there's a voting system based off of how many participants that you have. And at the end of the day, this turns into these really large technical documents and technical specifications. And from there, those are pushed out to the different partners and the different regional groups that are responsible then for turning them into real technology. So for North America, it's ADIS, and you can see that in ETSI is in the EU, and there's different ones for different countries. And now, if you want to go to a 3GPP meeting, you have to be a member of one of these organizations. So NI participates, and we're members of ETSI. So we lead our 3GPP work out of our office in Dresden, Germany. And then there's a bunch of different requirement sharing and spec sharing back and forth. There's groups that are also working on developing protocols and testing. There's a whole bunch of market partners like GSMA that help with marketing. They're the ones that put on Mobile World Congress. So it's really this like entire ecosystem that makes 3GPP work. And so I wanted to at least call this out because I think one of the things that gets shown a lot is what is the ITU's vision for 6G. And so I just wanted to be clear, the ITU is ones that are defining these requirements, and then 3GPP tries to implement them. And so for 6G in particular, the ITU set out a bunch of different, or 6 different use scenarios. So we have 3 that kind of were leveraged from 5G, enhanced mobile broadband, massive machine type control, and ultra reliable communications. And we've taken those and kind of expanded them. And then they've added in 3 new ones. So ubiquitous connectivity, you can think of this as trying to finally solve the problem of true global cellular connectivity. AI and communications, obviously AI is everywhere. And then integrated sensing and communications. And then throughout that, I think maybe the 4 things that I heard a lot about several years ago, but I've heard less in the last couple of years, sustainability. There's a lot of work being done around the Paris Climate Accord, net zero commitments that were made. So sustainability is a big part of it. Even if the US isn't as focused on that, it's certainly a big deal in Europe and in other parts of the world. Um, Connecting the unconnected kind of goes with that ubiquitous connectivity, ubiquitous intelligence, so the idea of having more things that are connected, and then security and resilience. So this isn't an area where I personally spend much time, but it's certainly important. And one thing that's not noted in this presentation, but that gets called out for 6G, is needing to address quantum. So we're assuming, we have 10-year cycles for wireless standards, and at some point in there, quantum cryptography could be realized. And so putting together 6G, that's something that we're thinking about. So as I kind of alluded to, there's a lot going on within 3GPP. And this is a very rough diagram of how it's organized, where there's, sorry, I'll go to the next one where I have my acronyms spelled out for you. There's different working groups. So TSGs are the technical steering groups, WGs are the working groups, working on the radio access network, which is the technical steering group for the RAN. There's service and architecture, core network terminal, and then GSM and edge RAN. And then within that, there's even more. And again, people make their entire careers going and doing 3GPP standards and focusing on different things. Where NI does most of our focus, and I think where a lot of the research that the folks in AirPaw are doing are going to fall into kind of that working group 1, the RAN 1, looking at physical layer aspects, and potentially getting into a little bit of layer 2 and layer 3, which would be working group 2. And then we're a test and measurement company, so we look at RAN 4 as well, which is where performance aspects as well as conformance testing come into play. And RAN 5 is really focused on the UE conformance. So just last quick plug, I don't think anyone here necessarily attends 3GPP meetings, but if you do, this is the team of folks who are involved on the NI side. I encourage you, please reach out, come talk to us. We're more than happy to have a conversation. Or, on the flip side, if you're looking at something and just have a question of what's going on in the 3GPP, this is the group of folks at NI who are focused on that. So you can see I sit on the marketing team, but I very much try and follow all of the activity and stay up to date on trends and what's making this technology work. All right, so that's just a really quick high-level overview of what the 3GPP is. So let's dive into what's actually happening today. So I mentioned the typical cycle for a 3GPP standard is 10 years. And I know in 5G, they said, oh, let's do it faster. We can do it faster. And in 6G, they said, we can do it faster. But in reality, it just takes about 10 years to get everything done. There's a period of industry research. So people taking interesting new concepts and ideas and building prototypes, building initial early versions and testing it out, making sure it works. And then from there, going and developing a spec, and research ongoing, and then from the spec, putting it into these documents that are being consensus driven, the community is discussing, and figuring out what gets accepted, what doesn't get accepted, the spec gets solidified, and then it actually has to be deployed into working technology. So for 6G, the first major workshop was held in 2025, and we're expecting release 21 to be the first version that gets into 6G commercialization. And currently we're within release 20, where we're working on the study items. So we're studying the different things that could be part of 6G. And then there will be work items. So turning those study items into real technology will be in release 21. When release 21 gets finalized in 2028-ish timeframe, that's when everything will kind of be passed back over. ITU will review it, give it its blessing, and then companies will start turning that into finished technology. Now, there is still work happening on the 5G side of things. We are working at finishing the 5G Advance in release 20. So looking at specifically, there's 3 areas that are being looked at for NTN, ISAC, and AIML. Within NTN, they're looking at GNSS resilient operations. So how are we doing things with satellites? ISAC, they're specifically looking at the UAV monostatic sensing on the base station side, and can we use existing waveforms? So we could do a whole presentation on ISAC, but there's a conversation of do we modify the comms waveform, or do we try and use digital signal processing to gain insight for the sensing side of things. And specifically right now in release 20, they're looking at, monostatic. So you've got the one-to-one for the UAV, and then using those existing waveforms in DSP. And then in the AI/ML side, they're looking at dual-sided models, which refers to using different ML models and that are trained differently for the base station side versus the handset side. And this is something that's formed out of necessity. I think in an ideal world, we would have a single model and a single set of training data that would be shared. But in reality, this is a capitalist business. And so the base station side wants to, keep their models and keep their IP and keep their training data as kind of intellectual property, and the same thing on the handset side. So we're trying to figure out how to make all that work together. So things that are still going on that are considered 5G. And then they're also working on that technology study of what's going to be recommended for the normative phase, that first version of 6G. And that first version of 6G is going to be coming in release 21. Now, in release 20, so is what's part of the technology study, they're coming up with these recommendations. So between July of last year and June, this past month, we've been collecting the different scenarios and requirements. There was a kickoff to look at the waveforms, coding and modulation frame structure, energy efficiency. I've got more details on all of that. In October of last year, they were looking at the RF test aspects. So things like, like talking about noise figure, EVM measurements, output power, things along those lines. February, there was another workshop to look at MIMO, NTN, non-terrestrial network, spectrum aggregation and sharing, and duplex operation. And then finally in April, there's one to look more deeply at ISAC. And then in June, in the plenary, so the plenary is outside of, kind of the RAN 1, 2, 3, 4, or any specific layer of the communication protocol. It's kind of looking at the RAN as a whole. And the plenary meets once a quarter. And so the June meeting was to approve the different 6G scenarios, review the technology items, and then make any adjustments to the schedule as needed. And now, as I mentioned, release 21 is the first release where we'll actually be doing work on 6G, and it's expected, the majority is expected to finish around the end of 28. And then this kind of like last area here is like things will be frozen, so they're not taking any more inputs, but it's finalizing all of the documentation, getting that blessing from the ITU, and turning it into something that commercial vendors can use. So let's talk about the actual technology and what's going into it. Now, every company that you look at is going to have a different view of what makes up 6G. And so this is just NI's take on it. There's a lot of different technologies that are happening, a lot of different applications that are being studied, but we broke it up and we see kind of like three key trends. There's a cost reduction, spectral efficiency play, and then looking at new revenue streams. I think anyone who's been in this space and listens to a commercial person give a talk about 5G or 6G, there's a lot of, we didn't meet the business case needs for 5G. So how are we going to actually make money? And so, it's especially for the folks here working on AirPod, I know you guys are doing a lot around integrated sensing and communications, the ISAC, JCAS piece of it. And that is being pitched as one of the biggest potential ways to get new revenue streams. And, I think anyone is capable of doing the signal processing, and there's a lot that could be done. But the propositions that I've heard are saying, well, almost this like sensing as a service. And so what can we take? What kind of information can we gather, do all of the signal processing, at the base station, and then sell that pre-processed data as a service to upstream users to give them information about, location, the physical dimensions and things that are around them, all kinds of things. So that's a big, important revenue stream. For spectral efficiency, obviously looking at the next generation of MIMO, depending on which company you look at, they have different names for it, but really it's going beyond the 64 by 64, 128, and so on. And then also looking at the FR3 spectrum. And then for cost reduction, energy efficiency actually comes in here. So I know that sustainability is really important for a lot of reasons, but it's getting picked up because it has the potential to save money. Um, because energy efficiency comes from using less energy, and everyone, I think, who's been following the news and things related to data centers, our electric bills are going up. The cost of electricity is increasing. So anything to use less electricity at the base station has an immediate effect on the OpEx. And then, of course, AI is just through everything. I think we're all seeing that as engineers and scientists, AI proliferates throughout. And so on the spectrum side, uh, we're starting to see a little bit more clarity into what spectrum is going to be used. I know, even looking back, like probably about 3, 4 years, sub-terahertz was really popular as a research topic, and there's a lot of conversation around, getting sub-terahertz into 6G. In reality, though, I don't think it's going to happen in probably definitely not in the first like 6G. It might happen in 6G advanced, but it's certainly an area that's interesting for research. There's a ton of bandwidth available, and there's unlicensed spectrum, but it has limited propagation because of the frequency. So things like traveling through different substrates is a challenge. So there's certainly applications where sub-terahertz is really interesting. The one that I think is the most compelling is things around like gesture control, and that ties in the idea of ISAC. So if you had like some of the augmented reality headsets, they'll have sensors around the top that are actually doing sub-terahertz that can do communications back and forth between the headset and whatever it's tethered to, but then can also, recognize gestures and see by the way that the electromagnetic environment is changing, and based off what you're doing, do gesture recognition. So very cool stuff still happening there, but not going to really be part of the 6G standard. In the mid-band, they've prioritized the bands listed here. I think that, the areas that are new and worth talking about, the 7.125 to 8.4, it has propagation characteristics similar to FR1. And then looking at the 18.4 to 15.53 for FR2 like, and then in the US in particular, we have a band around 13 gigahertz that has been allocated for study. But I also want to call out too, with 6G, we have a whole new play into looking at, what bands are allocated for terrestrial coverage, and then what bands are being requested for non-terrestrial, so for satellite coverage. And we have to be, it's good to at least be aware that there's conversations around what can satellite companies use for commercial communications, because there are a lot of incumbents here. And for anyone who follows the space, Cellular doesn't share well. We're really bad at it. We've tried a lot of different things in the past, like sharing with Wi-Fi in the 2.4 or 5.9 gigahertz band with like things like listen before talk, but like Cellular is pretty greedy. And so if we truly want to do communications and leverage some of these satellite bands, we're going to have to get better at it. So active area of research. So diving in on the performance side of things. Now, this is an eye chart. I'm certainly not going to talk about everything here, but it's worth noting that there's two different versions that we're talking about. We're looking at that non-terrestrial side of things, as well as terrestrial. So calling them out as two different ones, and acknowledging that for non-terrestrial, they could have like a truly massive amount of antennas, up to 100 or 1024. And for the base stations, you can see, depending on the frequency that they're looking at, there's we are scaling up from where we were in 5G, but not nearly kind of at the massive level. We're also, there's some improvements on the max aggregated bandwidth side. And then just getting to getting some initial ideas around the noise figure on the UE side, as well as the output power. And so the initial numbers that we're seeing for noise figure are a directly proportional to the output power, and the phase noise related to the bandwidth and the max that are being called out here. So as far as the bandwidths go, there's some contention around what's going to happen. There are folks that are interested in having up to 400 megahertz of bandwidth in that FR3, the 7.1 to 8.4 gigahertz spectrum. And there are folks that are in support of it, and there are folks that are not. So the UE support of 400 megahertz for the uplink downlink is basically not possible, is what we're hearing from folks like Apple, Samsung, MediaTek, Google. So those are your handset vendors. But then looking at Qualcomm, Nokia, Docomo, Ericsson, those are your base station vendors, and they're saying, no, we should do 400 for the downlink. You can do a single component carrier. It's possible. And kind of the agreement that we're at right now is they are going to do 200 megahertz of max channel bandwidth. There's potential to do study for carrier aggregation on the UE side for 2 by 200. But that would really be for peak times. And it would, and it's just not something that's there now. It's going to be something that's going to be studied in the future. So this has been a little bit contentious, but I think we're coming to an agreement around what's going on there. Again, another eye chart where I don't necessarily want to read everything here, but just noting kind of some of the timelines that I touched on briefly for the different topics. The physical layer is already looking at waveform, frame structure, channel coding, and the modulation. And they've added in topics around MIMO, duplexing, spectrum utilization, aggregation, NTN, and other physical layer signals. So a lot of things aren't going to change from 5G. I think there's definitely a big emphasis of using 5G as much as possible and leveraging it, but they are looking at, things around the frame structure, things around the waveform, what can be changed and what can be optimized. So on the waveform, what is actually up for discussion? OFDM has come out once again as kind of the clear leader for the physical layer waveform. They're looking at different coding proposals, and there's looking at both using AI ML based as well as non-AI ML based. So I think it's important to just recognize within cellular, we've spent like the last 2 decades really highly optimizing a lot of our algorithms, and we get like very, very close to the theoretical max. And so there are spaces where just AI actually doesn't add that much versus the traditional methods. And so it's important to just call out that in this, there are people looking at the AI ML based ways to do low PAPR, but there's also a lot of work that's being done on non-AI ways because we have such a strong foundation there. There's also a conversation around fixed wireless access and doing uplink and downlink and increasing the QAM that's used there. There's also a conversation around constellation shaping, so probabilistic and geometric shaping. And just quick sidebar, I know I had to look up what probabilistic constellation shaping was when I first heard the term, but it's really it's a way of doing kind of weighting on the constellation where you would have kind of more symbols that fall in these in like the inner part of the constellation and less on the outer. And that makes it so that, if you're looking at a power amplifier and the actual like characteristics of design and how much power is used and energy efficiency and a whole bunch of other things, it's harder to get very clean constellations for the outer part of the symbols. And so by using probabilistically, like putting more towards the inside, we can have some potential energy shaping or energy savings there. So there's a conversation around probabilistic ones and including that. And then geometric is what it sounds like is like, can we do different geometries? So instead of having square QAM diagrams, can we do like a hexagon or an octagon? Now, there's not a lot of favor right now for the geometric, but it does seem like probabilistic is possible. There's pros and cons for either one, and there's a little bit of pushback from some of the base station side of doing the probabilistic, but again, it's up for consideration. On the numerology and duplex schemes and others, we're trying to take some lessons learned out of 5G and saying like less is more. In 5G, we had a lot of different options, a lot of different splits, a lot of different possibilities, and we want to avoid doing that in 6G. It's saying, okay, well, instead of having 3 different subcarrier spacings for a single frequency band, like let's avoid that. Let's just pick one. And so they're looking for FR1, so sub 6 gigahertz, doing FDD, 15 kilohertz sub-carrier spacing. If it's TDD, 30 kilohertz. And then same thing for the 7 gig band, 30 kilohertz. And then I believe we ended up, I would have to double check, but I think they ended up at 60 kilohertz for the 15 gigahertz band. But again, the intention is just to do one. And then for duplexing, they're also looking at using semi-static TDD as the primary scheme for 6G, so leveraging what we have for 5G, and then making improvements on the spectrum utilization. So you can just see based off of these charts for different carriers and different subcarrier spacings, there's not entire utilization all the time. And so saying uh, how can we increase that? And so the RAN 4 is really focused on using narrow channel bandwidths for spectrum utilization and getting to 95%. Now, on the MIMO side of things and using multi-antennas, there is work that's being done using 5G reference signals as the baseline for all 6G reference signal studies. In 5G, they also had up to 24 of the DMRS antenna ports. In 6G, they're looking at going up to 96. And they're also looking at doing, in 5G had multi-TRP support, but it was introduced late and inconsistent. And so they're trying to make that something that comes in day one as a feature for 6G. So lots of work on the MIMO side as well, doing like looking at time domain resource allocation, frequency domain resource allocation, and taking a lot of the learnings that kind of came late in 5G and incorporating that into 6G. All right, so integrated sensing and communications. I feel like some of you on the phone here might be more of an expert than I am on this particular topic, but it can mean a lot of different things where, it's as simple as it sounds is how can we leverage the incredibly wide array of network equipment that we have in the world to gather sensing information. So, if we have base stations deployed everywhere, they're putting out waves, what can we do with that? And I think there's a lot of really cool things that we can do on the research side and we should be doing on the research side and could absolutely make it into commercial technology. But from the 3GPP standpoint, it's looking at, can we, what can we do to get actual improvements? So it's sensing that can be done without any change to the spec isn't where 3GPP is focused. That would be taking waveforms and things that we already have and just applying DSP. 3GPP is looking and saying, what spec extensions do we need to enable this? So what time and frequency resources do we need to allocate? So do we need to change things in the waveform itself? How often is it going to happen? And what measurements are we going to be taking? So it's really kind of some of these basic level conversations around the physical layer are what 3GPP is trying to take into account for. Also, what would a measurement report look like? And how often would they be sent and who would receive that? So there's so much happening around ISAC that's really, really cool on the research side, but I want to just also frame this of the information that the standards body is trying to gather is maybe a little bit different than what some of the researchers like yourself would be looking at, but it's taking it to that base level and saying, how can we make 6G work for sensing and give the most flexibility at a waveform physical layer level, and then let other people build on top of that to do the really cool applications. So 3GPP is not trying to come in and say this is the sensing algorithm. That will be IP that's built on top, and is a revenue source for the IP creators and implementing. So as far as the use cases with it that 3GPP is looking at, there's object-centric sensing and then environmental sensing. So, do we want to evaluate UAVs, pedestrians, vehicles, or are we looking at things like in the environment? I know self-driving cars has come up a lot in 5G and not something that we were ever able to successfully implement. But ISAC could actually be something that could be complementary to that technology, where we're looking at roads and barriers, or even doing sensing assisted beam management. There are definitely some security challenges that I think are worth thinking about and worth considering, and how we're going to take that into play. And I think that also causes some concern, but especially when we think about doing location tracking. And those are just kind of all things that are going on as part of this conversation. So creating this nice, flexible waveform and standard that can be used for ISAC is hard. So it's one thing to come up with a technical solution that we can use for it, but it's very different to come up with that architecture proposal that could work for a lot of different folks. And so I would just, encourage you guys as you're doing this ISAC research to think, like, is there something that 3GPP could do, or something about the waveform that would need to fundamentally change to enable your research? And then also, how would that apply to others? And are there like commonalities in things that the industry should be considering? Because I think industry folks always, like, we're the ones that are actively driving these standards, but we're not always necessarily the ones that are pushing the research forward. That's why, the public-private partnerships and industry academia partnerships are really important to kind of get this type of information. So, and also we really over-engineered 5G, and we don't want to do that this year. So just, again, thinking about that. And kind of one of the examples that we could think of, I know the slide says like beam management, but side link communication is another one where it's just like, it's great, but it's an option. And like outside of a few use cases for like emergency communications, it never got implemented. Now I know, again, I think you guys probably know a lot of this, but looking at the different implementation options, what I've seen from everything around 3GPP that they're trying to get to, signal sharing, where we would use the same signal and just as it is like the end all be all goal, where we're using the base station, we don't have anything extra that's needed. But in reality, I think there's still questions around, like, is a communication signal being sent at the right time and the right frequency to be used for sensing, or would we have to send out additional signals on top of that? So that's kind of one of the fundamental questions that I have around like the true signal sharing. I think spectrum sharing definitely seems possible. Hardware sharing, there's also a possibility there, but again, like, the technology is emerging. And so that image did not come out very well. I have links to the actual documents if you want to go and read more about like what's being considered in the 3GPP state. But right now, they're striving to support the 6 different sensing modes of monostatic, bistatic, from the TRP side, UE side, UE to UE side, base station to UE. So there's kind of some different combinations that you can see that are illustrated here for when we're doing that sensing. And there's a strong push to kind of, at the very least, get 3 of them in there. There's a lot of work to be done until March of 2027 in creating the framework. So again, it's not necessarily trying to think of like what applications and the IP that's going to do those applications, but it's coming up with that framework to enable everyone to be able to do them on top of the network. So like I said, as you're doing this, if you have certain just like things that you think, man, we really have to have XYZ in the standard to make it successful, keep that in mind, and feel free to share that with us. That's great input. Build this one out too. So I think for ISAC, there's been a bunch of use cases already that are built on 5G. For example, drone detection as a form of monostatic sensing is big, and that's already being looked at as part of the work that happened in June. The 6G part has kicked off and it's going to leverage a lot of that, but we're already starting to see kind of initial examples. We don't have the links for these in here, but there's some examples that came out of Mobile World Congress back in early March, late February of this year. Like Qualcomm used one for doing sensing and intelligent classification. So again, kind of that drone detection. And then All Be Smart and LightOn used one. This is kind of an older example, but it's using it for, they call it indoor intruder detection. But And folks have been doing this with Wi-Fi for a long time, but it's like tracking people inside. And so they have some really nice videos on their website as well of that in action. And I'm sure you guys do too with all of your test bed. And I know I didn't have a chance to fully read the paper that you guys sent over, but I got a little sneak peek. And so some of the work that you're doing here absolutely falls in this area. All right. Now I know that you guys aren't focused on NTM, but it's a really important part of 3GPP that we're going into, and a really important part of 6G and just wireless right now in general. Uh, there's three different categories that we're seeing for commercial NTN. There's broadband data, narrowband data, and networks designed to connect to existing handsets. So, here in the US, I think we've already started to get peaks of NTN features. The iPhone that came out several years ago that has the ability to do emergency contact via satellite was kind of maybe the first commercial solution that got launched out. But there's a desire to expand beyond that and saying, well, can we use it as truly like you know as the base station. And so there's companies like Starlink that offer it for home internet and for broadband, but that's a static use case. And so when we think about doing the handset, now you have to think about mobile. And there's certainly a question of, will broadband ever really be realistic? I think right now too, if you're on T-Mobile, they have actually started rolling out some early versions. They have some partnership with space companies to start providing service. And so right now you can get, I think it's $10 a month, and you can get text messaging over satellite. So I personally live in a very rural area. I don't have cell service at my house. And so this would be something that I could get, text messages if I was wandering around in my neighborhood, and where currently I have nothing. But again, I think there's also, we pitch this as a way to provide ubiquitous connectivity, but we are at risk as an industry of overpromising and under-delivering, because while text messages are possible and maybe even some low level of streaming, I think getting gigabytes of data throughput in a mobile scenario we're like years away from doing that, if we'll ever be able to. The narrowband data though for like IoT devices, that has a very good use case and seems very technically viable. And as I mentioned for like SOS, we already have that today. And T-Mobile even lets anyone, regardless of whether you pay the fee or not, access their NTN network for SOS. And then there's this huge desire to make it so that you don't have to buy a new handset. I think especially for the carriers, they want to offer this as a service that they can just start immediately charging people for without forcing them to upgrade phones or forcing them to wait for new phones that have it. So what does all of that mean in terms of standardization? Well, work started on this a while ago. So we had channel models coming in all the way back in 2017 and looking at system architecture. And now we're looking at doing kind of resiliency and thinking about what it's going to be in 6G based off of, doing the LEO satellites and regenerative payload. The thing that I think is worth noting, just for anyone who's personally interested in this space and kind of following, is the companies involved are now starting to show up. I think these release 15, release 16, they were really done by the cellular community, not by the space community. And so now SpaceX has actually entered. They have a small delegation, and they're focused on using the release 19 new radio-based NTN. Amazon Space Mobile, AST Space Mobile has committed papers, and Amazon LEO, which was formerly Amazon Kuiper, is working on that as well. And so, the SpaceX team and Amazon team have both recruited former 3GPP participants from other companies, like folks like Apple, Intel, AT&T, and brought them in for their to lead the 3GPP teams. And so just this level of involvement and activity, I think, shows how serious this is as an area for companies that want to get into space. So we'll see what happens. I think there's a lot with NTN more than anything else. There's a lot of technology challenges and business cases that I think need to be worked out. Just as kind of like a statistic, to get a full constellation that could cover the US, it would require somewhere around 10,000 satellites. And so, if SpaceX wanted to put theirs up, that's 10,000 satellites they have to launch. And then Amazon would need to launch another 10,000, and that's expensive. So there's certainly like a business case side that will be getting fleshed out in the next couple of years of whether or not we can do this. But I think just, again, seeing three companies showing up tells us maybe that they think it is. All right, so some summary and conclusions, and then we'll open it up for Q&A. Overall, we learned a lot on 5G. I think 5G was a large evolution over, or I'll call it 5G was a large revolution over 4G and LTE, and 6G is going to be an evolution. So taking a lot of the work that was done on the core and on the base station side and on the physical layer and making improvements, taking lessons learned, and making that part of 6G so it can be more successful. But AI is everywhere. One of my colleagues called out when he just even a few years ago, there were like separate tracks and separate meetings and separate work items and study items around AI specifically. And that's no longer the case. It's just assumed that every work item and study item, AI is a part of that. And there's a discussion around AI for each one. So we've seen that shift already, and that's just going to continue. There's also a desire to add an additional capacity with that FR3 band, the 7.1 to 8.4, and getting the massive MIMO up to 512 elements. On the PHY side, OFDM still continues to reign supreme, but we're expecting enhancements to reduce the PAPR. The frequencies, the 200 megahertz bandwidth is more or less set, and we're looking at sub-carrier spacing around 30 kilohertz. And the conversation again around 400 megahertz is going to be carrier aggregation for two 200 megahertz bands. It's not like it's would really be only for certain use cases, and it's not going to be included in the first version. Yes. And then 2026 is really a year of study, but there's a lot of questions around kind of what's going to be next and what's coming up. So, we finished this initial requirement collection for 6G, and we're reviewing the status and looking at the progress. But the real work of taking all of this and starting to implement it into technology that can be commercially viable is going to get ramped up here in the next 6 months and really the next 2 years. So we're getting clarity on what 6G will be, but now we're gonna the rubber's gonna meet the road, and we're gonna have to start doing the real work. So with that, that was my last slide. I'm gonna go ahead and just stop sharing so I can see all of you and get back to the chat. But I'd love to take questions and any comments and discussion that you guys have.
Okay, thank you so much, Sarah. That was enlightening, especially for some of us who don't attend 3GPP discussion. There's a lot happening, and I think there's a lot more that is to come. So with this, we are a very small community still, and that's why we want to open it. It's more of a discussion. As you can see, it is hosted as a meeting rather than a typical webinar where people don't see each other. Here we see each other and we discuss. So feel free to come off mute with your video or your audio and ask questions what you want. And I will start it with this question, Sarah. As participants are preparing to ask their questions, I was just wondering, with all these things you were discussing, and as coming from the test bed, digital twin, and all this ecosystem, I was wondering, how can the test bed help to solve some of the challenges that we see and some of the challenges that are coming with 6G and all these technologies? If you can make that connection, probably it
Yeah,
will be good for our
yeah.
community.
I think having a test bed and trying things out, you're beyond the theoretical research. You're into that applied research side, and that's really where it's proving technologies can work, and that's where you can get into the if you have something that's really compelling, you could make it a spin-off. You can collaborate with industry. You're like doing the point where, and I think we're going to start lining up with the research that you're doing and where the 3GPP is, and also not just the standard side, but like the really fun kind of on top applications that we get to build that are going to make 6G really special and interesting and kind of, I don't know, invigorate the community again. So it's taking your learnings here and starting to think too. I think what would be interesting, in academia, you'd hate to start thinking just based off of a business case, but really asking yourself like, what is the use, the end use, the end application? How could industry make use of what we're doing? Because you have a way to prove out that the technology works. And that's what's really important about a test bed is it's not just simulation, it's not just theory, it's going out there and doing the real thing. And you also have a lot of learnings that are important for what's hard, what maybe didn't work so well, what changes are needed. And it's, now is that time to be starting to gather is like how do giving that input about things that you had to change on like the physical layer to make your application work and getting your learnings and bringing them back to industry so that we can all kind of benefit from the research that you're doing. And that does happen through publications, but it's forums like this and conferences as well are a great time to have some of those conversations. Like I know you guys are hosting a new radio conference this year. We're super excited. And that'll be a great time for face-to-face. So I encourage anyone here who's kind of like, thinking about this or just might not have a question today, but like let's have a conversation about your research and what you're doing. I'd love to hear your lessons learned and your struggles would be a really interesting point too for kind of folks on the industry side of what works well, what doesn't work well, going forward to make the next generation of technology happen.
Thank you. Thank you so much, Sarah. Yes, we love the collaboration between academia and industry.
Yeah.
And I think that's what out of the other thing, like the technology side, from the collaboration side, the test bed has been that connection that was missing with the
Yeah.
academia and industry. Right now, I'm sitting here in a trailer and I'm looking outside the window. We have industry partners doing the demo today. Actually, we
Oh,
have we
great.
have the partners there, and we have all the U.S. government and other people outside there doing the demo. And that's what we really like to have that collaboration because we have the academia side we are looking for challenges to solve, right? And you
Yeah.
have lots of them in the industry. And that joint work, it works really, really well. I don't want to talk a lot, but anyone with a question, and if you don't want to come off mute, you can also type in the chat. We will see your question.
Yeah. And if not, I'll see you guys in September. Really looking forward
Oh, you're
to
coming. You're
I
coming
will be
to
there.
Gianacom.
Yep.
Oh, wonderful,
So
wonderful.
yeah, looking forward to seeing your
Yes.
test bed and everything. I know the work that AirPod's has been great, and it's so great to see. Like 10 years ago, this was an idea of having the industry and academia collaboration. So just yeah, finally seeing like the fruits of all of our struggles is
Oh, that's
fantastic.
stunning.
So yeah,
You're right. Yes, welcome. And we have airport demo. The last day of the conference on Friday morning, it's demo throughout mid-afternoon.
perfect.
So we'll be in the field. Put on your hat, your sunscreen, your sunglasses. It's gonna be hot. Probably not. It's not gonna be hot, but it's gonna be good weather in September.
Absolutely.
So that's if there is no question, we still have 7 minutes. I can be around here. I don't know, Sarah, if you have 7 more minutes, you can hang around and whoever want to stay. I see other people have dropped already, but if there's any question, we would love to take it.
Like I said, if not, I look forward to meeting all of you guys in a few
And
months
so,
and
right,
yeah, seeing what you
looking for.
seeing everything in person.
Yes, and we have, I don't know if you have attended JRCon before. Probably you have. It will be my first time, and I'm told that there's a lot. It's more. We have academia. We have technology interests, like just they have interests. Then they just have the thing they work out of their garage, and they want to show to the community how these
Yep.
things work. And I look forward to it as well. Look forward to
Yeah.
the JRCon. We look forward to hosting all of you.
Yeah.
And yes, Gautam, thank you so much. Thank you so much, Sarah, for your
Oh,
time. And
absolutely.
we look forward to continue working with NI in so many other areas. We welcome NI at the airport, and we can do industry demos here and demonstrate how all of this works and how we can solve the community challenges.
Yeah. Sounds great.
Sounds great. Thank you so much.
All right. Thanks, everyone.
Okay. Bye
Have a good
bye.
Thank
day.
Bye,
you.
Sarah.
Yeah.
Bye. Bye bye,
Bye.
everyone.
Bye.
Bye.